So let's move to question number 9. Let's see what the question says. In question number 9, it says state how is the distance traveled in any part of the graph determined from this graph. Well, this is a velocity time graph, which means this is the velocity and this is time. And I remember that the area enclosed by that curve gives me the distance. So this is area enclosed under the curve. Part 2. Compare the distance traveled in part BC with the distance traveled in part AB. Okay, so distance traveled in part BC where the velocity is constant and where the velocity is increasing. So how do you calculate the distance traveled? Let's calculate then. So distance in traveled in part AB is equal to area of triangle ABT, which is equal to half, since it's a right, this is a right angle triangle, this is base, which is AT, which is T, into height, which is V0. So this is equal to V0 into T upon 2. Now let's look at the area traveled in distance in BC, now which is this figure. This looks like a rectangle, so area will be area of rectangle BC to T and T. Yeah, this is, let's call this point D, let's call this point E. So we will call it BCDE, which will be length into breadth. So length is T to T, which means this total length is T, and the height is still the same, which is V0. So what do we have to do? We have to compare. So compare always means comparing in ratio. So we need to compare distance traveled in BC, which means T into V0 divided by V0 into T upon 2, which is equal to T into V0 multiplied by 2 upon V0 into T. This gets cancelled, so the ratio is 2:1. Let's look at part 3. Which of the part of the graph shows motion with uniform velocity? So uniform velocity, which means that the velocity is not changing. This is part BC because the velocity is not changing. Uniform acceleration. This is where the velocity is increasing. So this is part AB. And the last part, retardation. This is where the velocity is reducing, which means this is part CD. There's a fourth part to the question which is not here. Let's go. I'll read out the fourth part. Fourth part says, is the magnitude of acceleration higher or lower than the retardation? Now, which is a steeper line? Is CD a steeper line, which is retardation, or is AB a steeper line, which is acceleration? And to me, CD looks a steeper line. So CD, which is retardation, is more than AB. I'm talking about the slope here. So slope CD is more than slope of AB, so which is acceleration. So the answer is retardation is more than acceleration. Give a reason. Because slope of AB or slope of CD is more than slope of AB. That's my reason. Last part, compare the magnitude of acceleration and retardation. So how do we calculate the acceleration? We calculate the slope. So let's calculate slope of AB, y2 minus y1 upon x2 minus x1, which means this is equal to v0 upon t. And slope of CD, in this case, this is 2.5t up and 2t, which means this is only 0.5t. And this is still v0. This is y2 minus y1 will be v0, and x2 minus x1 is this. So let's compare magnitude of acceleration retardation, which means acceleration is AP, so v0 upon t divided by V0 upon 0.5t, which is equal to V0 upon t into 0.5t upon V0. This gets cancelled, this gets cancelled. So I'm left with 0.5 is to 1, which is 1 is to 2. So let's move on to question number 10. The velocity time graph is given. We need to find acceleration. So if I remember, then the acceleration is given by the slope. So acceleration for part AB will be given by the slope of AB, which is equal to y2 minus y1 upon x2 minus x1. In this case, for us, simply for our convenience, I've already written the numbers. So it is 30 minus 0 upon 4 minus 0, which is equal to 30 upon 4, which is equal to 7.5 meter per second square. Let's look at part 2 for slope BC, which is slope BC. Now I don't even need to calculate. I notice that this is a straight line parallel to the x-axis, which means it is moving at a constant velocity, which means acceleration is 0. Let's look at part C, which is slope of CD. Now I notice that this is a negative slope. It is curving down, going down. So, but still let's calculate it. Y2 minus y1 upon x2 minus x1, which is 30 minus 0 upon 8 minus 10, which is 30 upon negative 2, which is negative 15 meter per second square, which means it is a negative acceleration, or I may also call it deceleration. Let's call the second part. The second part is displacement. I remember displacement is equal to area under the curve. So area under the curve. So let's look at displacement in AB. So AB is the area under the curve is this much. This is a triangle. So let me name this point E. So it is equal to area of triangle ABE, which is equal to half into base, which is 4, into height, which is 30. So this is equal to 1 to 60 meter. And displacement in BC, which is my second part, will be equal to area of BC, which means this is the area that we're looking at. This is a rectangle, so area of rectangle BC FE. So BC FE, which is equal to base into height. 4 minus 8 is 4 into 30, which is 120 meter. And part 3 is displacement in CD, which will be equal to area of triangle CBD, which is again a half base, which is 8 to 10, which is 2 into 30, which is 30 meter. And the last part is total displacement. So total displacement will be 60 plus 120 plus 30. So total displacement is equal to 60 plus 120 plus 30, which is equal to 210 meter.